As I promised in the last video, we're going to solve logarithmic equations. Aren't you excited? We've got 18 previous videos now that are linked in this description, and you can click on them anytime you want if you need extra help. So as I said in the previous video, the intensity of an earthquake, the loudness of a sound, and compound interest on a loan are all applications of exponential and logarithmic equations. And equations that contain logarithmic expressions are logarithmic equations. We solve them by converting them to equivalent exponential equations. And to solve log base 2 of x equals -3, well, we already see our exponent, don't we? We convert it to x equals 2 to the -3rd power. We find that x is 1/8. To solve logarithmic equations, we first try to get a single logarithmic expression on one side of the equation, and then we write an equivalent exponential equation. So to solve log base 3 of 5x plus 7 equals 2, we already have a single logarithmic expression. So we write an equivalent exponential equation. So we can see the base is 3 and our exponent is 2. So we've got 5x plus 7 equals 3 squared. This is too easy. That's going to be a 9, isn't it? We can add a -7 to each side to get rid of this. Make a zero pair, additive inverse. We get 5x equals 2. We divide both sides by the coefficient 5. We get that x is 2/5. Now what's important is that we check this. So we had our log base 3 of 5x plus 7 equals 2. We put in our 2/5 whatever there was an x. And it works out that log base 3 of 9, well, yeah, that is 2. That does work out. What exponent makes this 3 and 9? A 2. It worked. Okay? If we see log x plus log x minus 3 equals 1, first we need to get a single logarithmic equation. Now remember, we have this plus sign here. Do you remember that theorem? Log of a product. It said that if you're multiplying these, we can write it as a plus, remember, as addends. So keep this in mind, all right? So this log x plus log x minus 3 equals 1, using that log of a product theorem, see? We get log x times x minus 3 equals 1. We convert it to an equivalent exponential equation. So we've x times x minus 3 equals 10 to the first power. We distribute this x. We get x squared minus 3x equals 10. Now we have to set it to equal 0. So we're going to add a -10 to each side of the equal sign. Now we get this nice polynomial that equals 0. And we factor it and use the principle of zero products. We have x plus 2 equals 0 and x minus 5 equals 0. That means x is equal to a -2 or x is equal to a 5. Now, this one, keep your eye on that one. The possible solutions to logarithmic equations need to be checked because domains of logarithmic functions are only positive numbers. If we put this -2 in, we see that it doesn't work. It doesn't equal 1. -2 isn't a solution because negative numbers don't have logarithms. We put the 5 in, and remember, when they're addends, we multiply. So we have log 10. Remember, because of our, here it is, our theorem, okay? So we're going to do the 5 times the 2, we're going to get a 10, and yeah, it worked. So we know the solution must be a 5, all right? That wasn't too bad, was it? Our next video is 12.7c, and we're going to solve problems that involve both exponential and logarithmic equations. I'm going to put it together. I've got 18 previous videos that are linked in this description. I'm going to add this to the Algebra 2 playlist. All you have to do is click on the links to get the video you want. We've only got a handful of videos left for Algebra 2. All right? I'll see you next video. Bye.